Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 11 on Stoichiometry, Section 1. And today we're going to learn how to convert moles to mass. So there is no scale to measure moles, so we have to convert moles to mass. Please write that down. So the first thing we're going to do is kind of look at that overview. We're going to do moles of our known, convert that to moles of your unknown, and then convert that to your mass of your unknown. So how do we solve a mole to mass problem? Well, the first thing we do is write a balanced chemical equation. The next thing we're going to do is we're going to figure out the mole ratio of your unknown over your known. Then you're going to find the molar mass of your unknown and set up the problem and calculate. So your moles of your known over 1 times your mole ratio, unknown over known, times your molar mass of your unknown over 1 mole equals your moles of your unknown. Okay, so let's look at a problem. And I already made a whole video and none of the sound recorded, so I have some of these already worked through, so lucky us. So please write this down. What mass of magnesium oxide is formed by burning 2 moles of magnesium in the presence of oxygen? First thing we always do is write down what we know. And that's easy here. We have it underlined, 2 moles of magnesium, and we're looking for the mass of magnesium oxide. And we know magnesium oxide is MgO. Okay, then when we're calculating it, you're going to write the balanced chemical equation. So let's look at this. We're combining what mass of magnesium oxide is formed, so that's our product. And we know it's MgO. So we have magnesium, which is a solid, plus O2 gas, is going to yield magnesium oxide, which is an ionic compound, so it's solid. And I have O2 here, so this is going to have to be a 2, which means I'm going to have to balance my magnesium. Great. Then we're going to figure out the mole ratio, which remember comes from this balanced chemical equation. Our unknown is magnesium oxide. So we put that one on top. 2 moles of magnesium oxide are going to have a reaction with 2 moles of magnesium, and I do see that this is the same as that, but it is very rarely the same, so always make sure you get your mole ratios from your balanced chemical equation. Now you're also going to need to know your molar mass of your unknown, and this is where you're going to need your periodic table. So magnesium is something like 24, and then oxygen is 16. We add those together, you get 40.31 grams. So we're going to set up the problem and calculate. You have your moles of your known over your mole ratio times your molar mass of your unknown equals your mass of your unknown. So our moles of known was 2 moles of magnesium over 1. Times our mole ratio from our balanced chemical equation was 2 moles of magnesium over 2 moles of magnesium oxide over 2 moles of magnesium. And our molar mass of our unknown, which is magnesium oxide, is 40.31 grams over 1 mole. And then we're going to slash out the units that we don't need, and we're left with grams magnesium oxide, which is 80.62 grams magnesium oxide. And when we look at sig figs, we get 3, so that's 80.6 grams magnesium oxide. We're going to do a check. Hopefully we earn that smiley face. What mass of magnesium oxide is formed? Did we answer what mass of magnesium oxide? Yes, we did. Now let's see, is it a reasonable answer? I started out with 2 moles of magnesium. Looking at my balanced chemical equation, 2 moles of magnesium will produce 2 moles of magnesium oxide, and each mole is about 40 grams, so 2 moles would be about 80 grams. Yes, we did earn that smiley face. All right, now it's your turn. So please write this down. What mass in grams of carbon dioxide is needed to react with 3 moles of H2O in the photosynthesis reaction where Carbon dioxide and water react to form glucose, C6H12O6, and oxygen gas. So remember to write a balanced chemical equation and write out all your steps and get the answer. Okay, now that you have that, let's flip it around. So instead of a mole to mass, we're going to do a mass to mole calculation. So this time, you're going to figure out your mass of your known, convert that to your moles of your known, and then convert that to your moles of your unknown. So how to solve a mass to mole problem? Well, the first thing you're going to do is write a balanced chemical equation. Then you're going to find the molar mass of your known, and it's actually 1 over the molar mass. Then you're going to figure out your mole ratio, which is unknown over known, and set up the problem and calculate. So your mass of your known over 1 times 1 mole over your molar mass of your known times the mole ratio of your unknown over your known equals your moles of your unknown. Okay, so let's look at this example together. Please write it down. How many moles of mercury 2 oxide are needed to produce 125 grams of oxygen gas in the decomposition reaction? So let's write down what we know. Well, we know we have 125 grams of oxygen gas, and we're looking for moles of mercury 2 oxide. So the next thing we need to do is write a balanced chemical equation. Well, how many moles of mercury 2 oxide are needed to produce 125 grams of oxygen gas? So oxygen is a product in the decomposition reaction. I'm decomposing it, so I'm going to start with my compound. So my compound is mercury oxide, and it's an ionic compound, so it's going to be solid. It's going to decompose into oxygen gas and mercury, which is liquid. So I have 2 oxygens, so I need 2 of these, which means I need 2 of those. Then I'm going to find the molar mass of my known, which is my oxygen. So let's do that. Okay, well, oxygen is O2, so it's going to be 16 plus 16, or 32.00 grams. And we know it's going to be 1 mole over, actually. All right, we're going to figure out our mole ratio. So we're looking at mercury oxide and oxygen. So mercury oxide is 2 and oxygen is 1. And our unknown, mercury oxide, goes on the top. So 2 moles mercury oxide over 1 mole oxygen is our mole ratio. All right, so let's set up our problem and calculate. We're starting of our mass that we know. We started out with 125 grams of oxygen. 125 grams O2 over 1 times my molar mass. So 1 mole of oxygen over 32 grams. 1 mole O2 over 32.00 grams times my mole ratio, 2 moles of mercury oxide over 1 mole of oxygen. Okay, so let's see. I cancel out grams O2. I cancel out moles O2, and I'm left with moles of mercury oxide. Then I'm going to calculate that, 125 times 2 divided by 32, and you want to grab out your calculator. Okay, and then we get 7.81 grams mercury. And if we look, we have 125, that's 3 sig figs, so I get 3 sig figs. Great. Now we're going to double check our answer. So did we answer the question? How many moles of mercury oxide? Yes, we did. No, we did not. Moles, let's see. Uh-oh. I hope you guys caught the unit error. It's not grams, it was moles all along. 7.81 moles mercury oxide. There's a big difference there. You caught it. Good job. All right. Did we answer the question? How many moles mercury oxide? Yes. Did we use sig figs? Yes. Now let's look at our, if it's reasonable, 125 grams of oxygen, and it's about, so let's say it's 120, and let's say 1 mole is about 30, so 120 and 30, 30 goes in there about 4 times, so we have about 4 moles, and so if this is O2, then we would have double that, so 8 moles. Okay, do we have about 8 moles? Yes, we do. So we have a reasonable answer. All right, so I'm going to have you try now. Whew. So liquid carbon disulfide is produced when carbon and sulfur dioxide are reacted together. If 8 grams of sulfur dioxide reacts, how many moles of carbon disulfide are made? And carbon monoxide is the other product. So liquid carbon disulfide and carbon monoxide are the products, and you know that carbon and sulfur dioxide are the reactants. So please set that up and solve for how many moles. Okay, in our next video we're going to put mass to moles and moles to mass calculations together into one calculation, and we're going to do mass to mass calculations. I'll see you then. Bye.